Hello, welcome to the video notes for lesson 10-7. I know it says lesson 11-7 at the top. Cross it out, change it. That was a typo that seems to have been stuck with us the whole time, so it needs to be 10-7, and I know that 10 looks terrible. Let me put another 1 in front. There we go. Solve a system of equations. So I can solve system of functions by graphing. Now, so we're going to be doing solving systems. That means more than one by graphing. We'll start with something very familiar to you, which is two linear systems, but then we're going to get into solving systems that involve other types of functions. Alright, so you will need your graphing calculator. Actually, you don't need it, but it becomes a lot more work without it. So I have mine. Before we use the graphing calculator, however, I need to transform these two equations, because right now they are in standard form. I want them to be in y equals mx plus b form. So I've got 4x minus 6y equals 12. I'll start with that one. First I'm going to add 6y to both sides. And then I have 4x equals 12 plus 6y. Now I'm going to subtract 12 from both sides. And I have 4x minus 12 equals 6y. To get y by itself, divide across by 6. And we get 4 over 6, or 2/3 x minus 2 equals y. So this is in y equals mx plus b form. Obviously you can switch around the two sides of the equation. The other equation needs to be transformed as well. We have 2x plus 2y equals 6. So first thing, I'll subtract 2x from both sides, and I get 2y equals 6 minus 2x. Divide through by 2. Now, even though it's not exactly in y equals mx plus b form, it's close enough. If you want to switch the 3 and the negative x around and make it negative x plus 3, that's fine. But now I have what I need to type this into my graphing calculator. Alright, so, and then what I need to do is make a couple tables and plot this. So I'll get my graphing calculator. I'm going to type in my first equation. I'll do 2/3, and it's probably, you could do 2x divided by 3 if you want, but you're still going to need parentheses for this so you don't get the wrong value for your y. And then I'm going to type in my other equation. Notice it graphed this one for me right here, and this is kind of a nice view that I have. I have the equation, the table, and the graph all together. And then I'm going to type in my 3 minus x, enter, and over here I've got everything I need. So, to make this work, I need to write down my two tables, my x and y values. For the first equation, I'm just going to use some values. I'll use the whole number values. So I've got -3, -4, 0, -2, 3, 0, and 6, 2. There's obviously more, but that's enough for me to see what I need. So -3, -4, put a dot, 0, -2, put a dot, 3, 0, put a dot. And now I can actually see the pattern, up 2 over 3, which is my slope, up 2 over 3. And if you want to use your slope-intercept form to help you come up with the points that's fine, but you should still use a table to show you've done your work. I'll use my line tool, and yes, you need to, you know what, I'm going to keep it as is, but I'll add my arrows in after. Yes, you need arrows, and yes, you need to label it with the original equation. So this is my 4x minus 6y equals 12. Remember, when you're solving linear systems, you can have one solution, you can have infinitely many solutions, or you can have no solutions. For the other one, I'll start my table, but I don't need, so how about -3, 6, -2, 5, -1, 4, 0, 3, 1, 2, 2, 1, 3, 0. That's enough. All right, so -3, 6, 6, -2, 5, and this is an easy one because the slope is 1 over 1, actually -1/1, and it looks like that. Use my line tool so I can make a nice straight line. This time I'll use my red. Don't forget the arrows. Don't forget the equation. 2x plus 2y equals 6. And there's my solution. There's one solution for this. It's 3, 0. Now, yes, you need to do the checks. I'll bump this down a little bit. So remember with the checks, you are going to, let me put it right over here underneath all the work for the appropriate section, ESS. So the original equation is 4x minus 6y equals 12. This only takes a second. Plug in your values, 3 and 0. 12 minus 0, 12 equals 12, and it checks. Check the other one, 2x plus 6y, 2x plus 2y equals 6. 2 times 3 plus 2 times 0, 6. 6 plus 0 equals 6. 6 equals 6, and it checks. Dun, dun, dun. Alright, so that was the first one. Easy. It's actually a little bit of a review. So, now we're going to take a look at page 40, graphing a quadratic in a linear system. So, now we're going to be dealing with a quadratic and a linear. So we've got two different types of functions. Graph the function, so here's our quadratic. F of x equals negative x squared plus 4x minus 3 for all values of x such that negative 1 up to 5. So in other words, they're giving us the domain for just the quadratic, which is wonderful. So over here, I'm going to write my f of x equals negative x squared plus 4x minus 3. This is my quadratic, x and f of x, or y if you want. Now I know my domain, my x values are going to go from negative 1 up to 5. That's actually kind of nice. Then, I'll divide this in half. I also have my linear, x plus y equals 1. I'm going to change that to y equals 1 minus x, or negative x plus 1. I just subtracted x from both sides to put it in the correct form. So x plus y equals 1. Let me switch to blue here. And I don't know what my domain and range are yet. I'll get an idea once I put this in my graph. Alright, so I still have that old junk in my calculator, so I'm going to clear that out. And then I'm going to type in my my quadratic function, so negative x squared plus 4x minus 3, enter. So, and you'll see over on the side this comes up. It's actually rather lovely. Then I also have my 1 minus x to put on here. Enter. And dun dun dun. There's my linear. And I see my table over here. I'm going to adjust this table just slightly because remember I want my domain for the quadratic to go from -1 to 5 so I can see all of that. Alright, so for my quadratic I've got -8, -3, 0, 1, 0, -3, -8. So you can start to see that parabola taking shape. So -1, -8, 2, 3, 5, 6, 7, 8. Put a dot. 0, -3, 1, 0, 2, 1. Keep going. It's turning out beautiful. That is a lovely parabola. Do the best you can making your parabola curve up and then back down. Do not put arrows. Your domain is very specific from -1 to 5. It does not keep going. You don't want to lose points for that. And then label. So we've got f of x equals -x squared plus 4x minus 3. Okay, now I'm going to, this time I'm looking at my table. I think I'll go from about -3 up to, I don't know, 3 or 4. -3, -2, -1, 0, 1, 2, 3, 4. That looks good. Alright, now, -3 starts at 4, and then 3, and then 2. So this has a -1/1 slope. So it's pretty simple to come up with your output or your y values. Oops, 2, -3. Plot your points. -3, 4, 4, -2, 3, and then so on. And it's pretty easy to plot this. Now this one they did not give you a domain for. So when you connect your points, you not only need to connect them in a nice straight line, but you also need to put dun 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 arrows at either end to show they continue. And this is x plus y equals 1. So this time we have two solutions, one here and one here. Come on, come on. Solutions. And we have the point 1, 0 and the point 4, -3. Now, we are not done. The last thing here says check the answer obtained in part C algebraically. So when you have an algebraic and a quadratic, let's think of possibilities. One possibility is that we hit this quadratic 2 times. Another possibility is the line in the parabola don't touch at all, so 0 solutions. And then another would be 1 solution. So just like when finding the roots, you have either 2, 1, or none. When you do the checks, what we need to do are 4 checks. You're going to be, look at that spelling. You are going to be checking the quadratic and the linear for the point 1, 0. Then you're going to check it again for the point 4, -3. And make sure that it works in both. And it will. Because this video is getting a little bit long, we're going to move on to page 41. Now we have a cubic and a linear. So, this time we're going to be graphing this function, x cubed plus 2, and here's our domain again. So, I'm going to just help you with the setup, and I'll let you finish the graph on your own. So, one table is going to be f of x equals x cubed plus 2. And we're going to be graphing from -2 up to 2. So you're going to plug this into your calculator. After you clear out all the old junk, you'll plug it into your calculator under Y1 and get your table. Then you have your linear. This time they were nice and they left it in the proper form. So we have g of x is equal to -2x plus 5. So this time I'll give you a suggestion for a domain. And your domain is going to be -2 all the way up to 4. So this domain is just one that I gave you. So technically your linear will continue. Make sure you put your arrows on. The cubic, however, ends. So don't put arrows for your cubic. Fill in the rest of this table, do the graphing, then find your solution. This one, there is one solution. So we can write it up here. Or actually, I put mine at the bottom because of my labels. So we're going to have one solution. And then you're going to have to do one check with both functions. And this will probably be pretty easy. Alright? So that's it for this video. If you found anything confusing, come and see me for help or get help from a friend. Good luck, and we will see you in math.